Hey everybody, and welcome back. If it's your first time here, welcome to this channel. I'm David Townsend. This is the Net Academy, where we are learning networks together. And this is part 7 of the series that I've been doing on EVPN-VXLAN, which stands for Ethernet Virtual Private Network, Virtual Extensible Local Area Network. As I always say and almost joke about, those are two big acronyms in one, because they're two great big, really powerful protocols that work together very, very well for data center networks as well as the enterprise networks in the campus fabric networks. But this is part 7, so obviously there's been parts 1 to 6. And those parts we touched on what are the fundamentals, what are the basics, what is the basic understanding that you need to know when it comes to EVPN and VXLAN. And on part 6, what we went through is the different types of EVPN routing when it came to the asymmetrical model and the symmetrical model. And what is the packet life journey when it comes to both of these different EVPN routing types. And what is a MAC VRF, which is very important to understand when it comes to the VXLAN world itself. So if you haven't seen those previous videos, especially those parts 1 to 5, I highly recommend you start there before going any further. You absolutely need to know what is an EVI, what is a VNI, generally what are the benefits of EVPN, and ideally those different EVPN route types before proceeding any further. And on this video, what we're actually going to go through is what are the different EVPN service models. Now, there are actually 3 different types of EVPN service models. We've got a VLAN based service interface, and then we've got a VLAN bundled or bundle service interface, and then there's a VLAN aware bundle service interface. And on this video, what we're actually going to go through is what are each one of these services, each one of these interfaces, how do they differ from each other? Generally, how do these relate to a MAC VRF, a VLAN, and an EVI? And there are subtle differences, and actually some quite big differences between these different VLAN services, these different VLAN interfaces. And this is going to pave the way very nicely to the EVPN route type 5. I'm not covering it in this video, but you need to know what are these different EVPN service models before we start talking about the EVPN route type 5. And that's why I've not covered it so far, because I want us to understand, yes, the basics and the different EVPN route types and the asymmetrical and symmetrical EVPN routing, but also what are these different EVPN service models before we actually start talking about that very specific EVPN route type 5, which has a very specific use case to it. So no more of me talking. I suggest let's just get straight onto the lab, straight into the theory, and start with the EVPN service model, which will be the VLAN based service interface. First though, I want to start with a quick recap into what is an EVI or an EVPN virtual instance, and what is a MAC VRF, how does that relate to both a VLAN and the VXLAN network identifier, the VNI. Very important to have a quick recap on that before going any further, trust me. So what I'm going to do is first just cover what is an EVI or EVPN virtual instance. So let's say, just for example, you've got 4 leaf devices, 4 switches here, here, and here. And I'm just going to give these a quick name. So I'm going to call this leaf 1, leaf 2, leaf 3, and leaf 4. Now, obviously, in the EVPN VXLAN world, each of these going to be a VXLAN tunnel endpoint or VTEP. Again, if you don't know what these acronyms are, please start off with the part 1 in this series. You definitely need to know these acronyms before going any further. But leaf 3 is a VTEP as well as leaf 4. And I'm just going to draw this little cloud in the middle, and they all have connection to this. I'm not going to draw a connection to each leaf device because it's just a quick recap at the end of the day. We don't need anything too in depth at this point. Now, an EVI is quite literally what are the interested devices that are participating in this EVPN domain. And because we're working alongside VXLAN tunnel endpoints, or VXLAN itself, let's say we've got EVI here EVI1, sorry, and that's relating to the virtual network identifier, the VXLAN network identifier 5010. So here we might have VTEP participating in 5010 on leaf 1, and leaf 2 might also be participating and interested in all the traffic that's going through that VNI tunnel 5010. And so leaf 1 will be configured and will be participating in that EVPN virtual instance, that EVPN domain of EVI1. So I'm going to do EVI1 here and EVI1 down here. Now let's just say, for example, we've also got a second EVI, so EVI2, which is aligned to the virtual network identifier 5020. I'm just making up any numbers, doesn't really matter. But let's say leaf 3 is configured to participate in the EVI domain 2, and on the VTEP we've got that tunnel configured of 5020. And leaf 4 is also configured to participate in EVI2 for the VXLAN tunnel 5020. So what this basically means is leaf 1 and leaf 2 are both participating in the EVPN domain of EVI1, and they are configured to send that EVPN traffic and that tunneled traffic from leaf 1 to leaf 2, but they're not going to send it to leaf 3 and leaf 4 because these are in different EVPN domains. And also they obviously have different tunnels. They might not be configured to carry tunnel traffic from 5010 to 5020 and back. I'm not saying it can't be done, but you would then need EVI1 on leaf 4 and on leaf 3, so that leaf 3 and 4 are interested and are participating in that EVPN domain. As literally what an EVI is, it's an Ethernet virtual private network, virtual instance. Virtual being, doesn't physically exist, but it's between those different leaf devices, those different switches, routers that are interested in that EVPN traffic within that virtual domain. And let's now just quickly do a quick recap on what is a MAC VRF. I call it VRF. You might call it different things, you know, different ways to pronounce virtual routing and forwarding. I'm just calling it VRF. It's just my way of doing it, okay? So I had a few comments saying, "No, Dave, why don't you try it this way?" It's like, okay, each to their own kind of thing. You know, you might like to say VRF, you might just like to say VRF, each to their own. But this is obviously immediate access control, virtual routing and forwarding function, or engine-table. So in the Mac world, we are obviously talking about layer 2 media access control. I don't want to teach anyone really the basics of layer 2, but obviously this is a 6-byte overhead identifying a particular tenant, a particular hardware encoded layer 2 address. And these layer 2 addresses are stored in the switching table, as it's commonly called. In the real world, that switching table is actually referring to the MAC address table. But here we're talking about a MAC VRF or MAC VRF. And we've also got this concept of a VNI, a virtual network identifier. But also related and aligned to the MAC VRF is a particular VLAN. And the VLAN is aligned to a particular VNI. Now, each one of these layer 2 MAC addresses, they may or may not be part of a particular VLAN. So they might be in a native VLAN, or they might be in some kind of configured VLAN. So let's just call it VLAN 10. Again, just throwing out numbers, just keeping it simple. So in the Mac VRF world, in the Mac VRF world, what this is it's quite literally storing the layer 2 MAC addresses for a VLAN and to the aligned, this is how I think of it, and to the aligned VNI. So that is what a Mac VRF is. It's a storage of those layer 2 MAC addresses which have a virtual network identifier aligned to it. And because every VNI has a VLAN, you're also going to see what is that VLAN. So if we draw it from a table perspective, it would quite literally look like this in my head. So we have our MAC address table, that switching table. I've just gave it a name here of 10. Whatever the MAC address table name actually is. Obviously, you can have different MAC address tables. So this is how it looks in my mind. So we've got our layer 2 domain. We've got our MAC address table here. I've just gave it a name of 10 here, but this is basically that layer 2 domain where we are storing all those MAC addresses for tenant A, tenant B, tenant C, which is aligned to this particular VLAN. We are going to obviously have a different MAC address table for every VLAN, hence I've just gave it a different name here, so a name of 10 relating to VLAN 10. And then this MAC address table is aligned to a particular MAC VRF. Again, I've just gave it a name here, 5010, because we're taking that VLAN ID of 10, or actually it's here, and we are aligning, we're configuring it to a particular VXLAN network identifier of 5010 here. So you typically will have, again, this is why we're doing this video, a MAC address table which is aligned to a particular MAC VRF with a VNI. And that MAC VRF will store all those MAC address entries for that VNI and, of course, that aligned virtual local area network, or VLAN. And as we went through in the last video, you're then also going to have an IRB, integrated routing and bridging interface. So here I've called it IRB10 for VLAN 10 and VNI 5010. And this will basically serve as that gateway to get out of the network if you want to do inter-domain, inter-VNI routing. And you have multiple, or maybe even one or several MAC VRFs in a particular IP VRF or IP VRF. But basically this then is aligned and configured to be participating in a particular EVI or EVPN virtual instance. Again, going back to what we were just saying, all an EVI is it's all leaf devices and all VTEPs that are interested and are participating in a particular EVPN domain and want to send traffic into that particular EVI and want to receive traffic from that particular EVI. So this is a quick recap on what is a MAC VRF and of course what is an EVI. So I had to go through these first, a quick recap on what is a MAC VRF and what is a EVI before going any further. And now we can actually start going through what is the VLAN based service interface. And so here we go. Here's the VLAN based service. I'm not going to keep calling it VLAN based service interface. I'm just going to say VLAN based or VLAN based service, just so you know moving forward. But with the VLAN based service, what this is it's a one-to-one mapping. And by that, what I'm referring to is it's a one-to-one mapping of a VLAN to a particular MAC VRF, which is then aligned to a particular VNI and even to a EVI. So everything is done on a one-to-one basis. So if we take a VLAN of 10, this will be aligned to a particular MAC VRF table, and it's a one-to-one mapping. So all those MAC address entries which are in that MAC address table for VLAN 10 will be aligned to a given MAC VRF, and that is aligned to a particular VNI, one-to-one mapping again, so let's say 5010, and let's say this is to a one-to-one mapping to the EVI of 1. So that is very quickly what a VLAN-based service interface is. It's a one-to-one mapping. We're taking that MAC address table, we're aligning it to a given and dedicated MAC VRF table, and that is then aligned to a dedicated VNI, and they all have their own EVI, their own EVPN virtual instance. So let's say, for example, here that on this device here and this device here, we want to send traffic to and from each other using the VLAN-based service interface. And I'm going to mix things up here. I'm actually going to say this is MAC table 10, and at the bottom let's say we've got MAC table 20 as well. And these are obviously those layer 2 domains, and of course that is for VLAN 10 and VLAN 20 down here. So I'm just going to draw a little box around these, and as I was just saying, these are then aligned to a particular and dedicated one-to-one mapping again, MAC VRF. So we've got MAC VRF here, and we've got a MAC VRF here for those different layer 2 switching tables at the end of the day. So each one of these MAC VRFs contains the MAC address entries for those VLAN tables, for those switching tables. So we got VLAN 20 here with all those MAC addresses in that MAC address table feeding into this MAC VRF table here. And likewise for all the MAC address entries which are in table 10 for VLAN 10 are fed into this MAC VRF there. And so what you can see just here is that there is a single bridge table within that MAC VRF. It's a one-to-one mapping at the end of the day. One-to-one being the big point here. But then these are aligned to a one-to-one mapping to a particular VNI. Oh, and I forgot to say that we have these within a different, well, I didn't forget, they're up here, but I forgot to draw it on. But MAC VRF for VLAN 10 for this particular MAC VRF table here, this could be aligned to be in EVI 10, just for example. And this MAC VRF table here would be aligned and configured to be in EVI 20. So again, they have their different EVIs. They will have different devices which are participating in that EVPN domain. And then these are sent with their individual virtual network identifiers. So this would be 5010 here and VNI 5020 here. And then it gets to the receiving devices, and if they're configured to participate in that EVI, they will also have exactly the same configuration, give or take, on the opposite end. So we'll have MAC table 10 for VLAN 10 here, and again this is the layer 2 domain, and down here we're going to have MAC table 20 for VLAN 20, and using the one-to-one mapping for the VLAN based service interface, these are then going to be aligned and configured to be in a particular MAC VRF, which stores all the MAC address entries for a particular VNI. We've got MAC VRF here, and MAC table 20 is aligned to that particular MAC VRF. And this would be again participating in EVI 20. This would be participating in EVI 10. And because of the configuration is one-to-one, these would then receive all of the traffic through that EVPN-VXLAN network, regardless of what that underlay actually is. So a big point here is that is a one-to-one mapping. We are taking that original switching table, the original VLAN table with all those MAC address entries, and we are aligning it into a dedicated MAC VRF table, which also has a dedicated EVPN virtual instance. Doesn't matter about the name. And for each one of these dedicated MAC VRFs, which contain all the MAC address entries for that given VLAN and the aligned VNI, we then have a dedicated VXLAN or virtual network identifier here. So everything is done on a one-to-one basis. And so what we can also take away is that the EVI, because it is a one-to-one mapping, it will represent an individual tenant or an individual subnet. This might be for VLAN 10, this could be 192.168.10.0 / whatever, and this could be 192.168.20.0, and that EVI for 20 and EVI for 10 will individually represent those individual subnets here, because everything's done on a one-to-one basis. But you also have to remember what goes into these update messages that are going throughout the network. So we also have within here a particular route target. So we're going to have a dedicated route target for this particular VTEP. This would obviously be a VTEP here, and this would be a VTEP here as well. But they, regardless of those update messages, whether it be route type 2, 3, 4, etc., they are all going to have a particular route target. And so that route target actually also uniquely identifies that layer 2 domain, because we have a particular VNI here of 5010 coming from this particular EVI, and that route target in itself will be unique. And because we have a particular VNI aligned to a particular MAC VRF and originally a MAC address table and all those MAC address entries in there, this route target will uniquely identify that layer 2 domain. And as such, there is no need to have that VLAN advertised throughout the network. So let me draw that a bit better actually. So let me just draw it right in the middle, so it looks like it's coming between the two different VTEPs. So we've got a VLAN obviously going to and from these different VTEPs, but with the VLAN based service interface, that VLAN is not included within those update messages themselves. So those root type 2s, those root type 3s, 4s, so on and so forth. So they're not included. The VLAN tag is not included in that overhead. And actually, coming back to that root target, because that root target identifies a particular layer 2 domain, because everything is again done on this one-to-one mapping here, this allows for very granular import of MAC addresses. So I'm just going to do MAC here. Granular import of MAC addresses. So you might have 1,000 MAC addresses coming into this MAC address table here, which then go into this MAC VLAN, which is aligned to EVI10 with this particular root target, and is then configured to be going through VNI tunnel 5010. On this point here, you might just only want to configure this device to receive 900 of that original 1000 over here. And because that is a unique root target using this VLAN based service interface model, it allows for that very granular control of what you want to import on that receiving device in terms of those MAC address entries, which is what EVPN is all about at the end of the day. And so I've tidied the display up a lot, but to summarize what the VLAN based service interface is, the big point to take away is that this is a 1-to-1 mapping. We have a MAC table, which is aligned to a MAC VRF or MAC VRF table, 1-to-1 mapping. And this is then aligned and configured to participate in a dedicated EVPN virtual instance. And this will also then have its own dedicated virtual network identifier. So everything is done on a 1-to-1 basis. And again, that VLAN is not carried in the update messages. Let me write that a bit better. There we go. So the VLAN is not carried in the update messages because we have a unique root target which identifies that layer 2 domain and also allows for granular MAC import on the receiving device. And of course that root target also identifies that MAC VRF table as well, because everything is again on a 1-to-1 basis. The EVPN virtual instance represents an individual tenant or subnet, and the VNI also represents or identifies the MAC VRF. At this point you might be wondering, well Dave, you've already said the root target identifies that layer 2 domain, and the layer 2 domain is aligned and configured to a unique MAC VRF. So why is the VNI doing the same thing? The difference being is that the root target is at the control plane. So at the control plane between these different devices here, that root target is identified at the control plane what is this layer 2 domain, and then allowing that granular MAC import of those received MAC addresses. What MAC addresses do you want to receive, which ones do you just not want to import into your routing table. Whereas the VNI is, guess what, at the data plane. So at the data plane, the VNI represents that receiving MAC VRF, that MAC VRF table. So just in summary there, we can see what a VLAN based service interface is. Everything is done on a 1-to-1 basis. I've kept it simple here and only had 2 devices here, so just to keep it simple, but the key takeaways are literally here. 1-to-1 mapping. You have a dedicated MAC VRF for every single layer 2 switching table. That MAC VRF table is aligned and configured to be within a given EVI, and that EVI will have a given virtual or VXLAN network identifier. And because we have a unique root target, it allows that granular import on the receiving device or those MAC address entries, and that identifies that layer 2 domain at the control plane, and that unique VNI which identifies that MAC VRF and those VLANs and all the MAC addresses within that VNI identifies that layer 2 domain at the data plane. So everything is 1-to-1. But how does this then differ to the next EVPN service model, which is the VLAN bundle service interface? And now we move on to the VLAN bundle service interface. And again, I'm just going to call this VLAN bundle or VLAN bundle service. I'm not going to say the whole thing, or I don't plan to, just so you're aware. And unlike the VLAN based service interface, which was a one-to-one, in this interface, in this EVPN service type, what this is a many-to-one service model. So before I go any further, what this quite literally is we are taking multiple or several or many, hence many to one, many switching tables, many VLAN tables that contain those MAC address entries of those end devices, and they are imported, aligned to a single MAC VRF or MAC FIRF. And just as it was before, that MAC VRF is aligned to a single I1 virtual network identifier, or that VXLAN network identifier. The acronym is virtual network identifier, but it doesn't really matter either way. And also, like the EVPN service model, that VLAN based service interface, there was a single EVI for that one-to-one mapping. In this model, in the VLAN bundle service interface, there is also a single EVI. So really the big difference before we go any further is we have multiple or several or many being the word, many original layer 2 domains, original layer 2 switching tables, i.e. MAC address tables, which are aligned to a single MAC VRF. And there are pros and cons to this, but first let's start drawing it out. So let's say we again have VLAN 10, and that's our layer 2 domain. And then we have VLAN 20, which is another layer 2 domain. And I'm just going to mix it up and make it a little bit more different now. And I'm also going to do VLAN 30, and there's a point why I'm doing this, which is another layer 2 domain. So obviously in each one of these switching tables, whether it be the switching table for VLAN 20, 30, or for VLAN 10, there are going to be X number of MAC address entries. But this is the bundle. We are bundling all of these layer 2 switching tables, these MAC address tables, into one MAC VRF. So let me just draw MAC VRF. And as I said, this is going to be aligned to a single EVPN virtual instance. So I'm going to call this EVI1. So we've got VLAN 10 with that layer 2 domain coming in. We've got VLAN 20 with that layer 2 domain being aligned to this MAC VRF as well. And guess what? Exactly the same for VLAN 30 with that layer 2 domain. This is also being aligned and configured to that EVI1, to that MAC VRF. And I've said before that this MAC VRF contains all of the MAC address entries for all of those tables, those switching tables, and the MAC VRF is further aligned to a virtual network identifier. But in the one-to-one model, this worked fine because this doesn't matter how many MAC VRF tables we actually had, it was a one-to-one mapping. But here we are aligning, in this case, 3 tables over to 1. And as such, in this model, you do need to ensure that all MAC addresses are absolutely unique. If you have duplicate or the same MAC address in VLAN 10, which is also just for example in VLAN 30, that's not going to go down too well. Honestly, I don't know what the impact of that would be, but obviously it's not going to be a positive outcome. So the MAC addresses need to be unique. You can't have the same MAC addresses, even if they are in different switching tables and aligned to different VLANs. You can't have them configured and aligned to that same MAC VRF in this VLAN bundled service interface model. And so I'm just going to call this MAC VRF1, and that is configured into EVI1. Now over here, in terms of this device over here, this is also in this EVPN service model going to be participating in EVI1. And if it is also configured in the VLAN bundle service interface, it of course is also going to have a MAC VRF, and we'll call this MAC VRF1 as well. And of course that will have a virtual network identifier for that VXLAN tunnel. And so let me just draw that there. And so what happens at this point when this device here, so let's call this leaf 1, and over here we have leaf 2. When it sends this traffic over from leaf 1 to leaf 2, this is going to have a virtual network identifier of, let's just call it 5000. Let's keep it simple. And it will also carry the original tag, the tag being the VLAN identifier. Now, before I go any further, it's important to note that this is at the data plane. VNI is referring to VXLAN. This is a data plane technology. However, when we're talking about those EVPN updates, when we have this VLAN bundle service interface, within those different route types, there will be no tag actually there, because EVPN is a control plane protocol. It's a signaling protocol. So for the EVPN bundle service interface, through the tunnel in the VXLAN, we will be carrying the original Ethernet tag. But in the EVPN route updates from leaf 1 over to leaf 2, the EVPN will not have that tag because that is at the control plane. However, referring to this tag information here, that tag will show either a tag ID of 10, 20 or 30 based on what is or where those MAC addresses are actually coming from, i.e. tenant A is aligned or is contained within VLAN 10, and so the tag would be VLAN 10. And also coming out this device, just like we did before, we've got a root target. Now, just as you need in any world when you talk about root target, you've got an import and an export. So the export is when leaf 1 would send a root target to be a specific value, and the import would be when leaf 2 is configured to allow the import of these received packets and these received update messages via EVPN if it's got the import for that same root target. If it doesn't have that same root target or it's not configured, it will just drop those packets that have been received and drop those update messages that have been received. But also the root target will actually identify the EVI that these received packets from leaf 2's perspective need to forward these packets onto. So the EVI being EVI1, as you can see on the diagram. But what also identifies what is the received EVI is that virtual network identifier, which is on the data plane. So both the root target and the virtual network identifier together identify to that receiving device what EVI do these received updates and these received packets actually belong to. Remember that leaf 2 here might have multiple or several EVIs. It might have EVI2, EVI3, EVI4, so on and so forth. So it needs a way to identify both at the control plane, which is where the root target sits, and at the data plane, which is where the VNI sits, what EVI do these received packets and update messages actually belong to. But here's the kicker, here's the downside to the VLAN bundle service interface. On the left hand side, we've got VLAN 10, VLAN 20 and VLAN 30, which are both, or all of them, sorry, been mapped and aligned into a single, i.e. many to one MAC VIF table 1 with a particular virtual network identifier, which I said was VNI 5000. Now, at the receiving device, when these data plane packets and these update messages at the control plane come through to leaf 2, this root target actually is identifying more the tenant than the destination subnets and the VLANs, the tenant being leaf 2 itself. When we were talking about the VLAN-based service interface, the root target was identifying the end destination, the destination being that particular subnet, that particular VLAN. But in this case, because we got, in this case, 3 different VLANs being mapped into a single MAC VRF, you can't really say using one root target what that actual end destination is in terms of that end VLAN, that end subnet. And as such, the root target in this VLAN bundle service interface is actually referring to the end tenant, the end receiving device, not the VLANs, not the subnets. And as such, the kicker here, as I was saying, is from leaf 2, when it's received those packets, it's going to import everything. So if it's got a VLAN 10 here for this layer 2 domain, and it's got another switching table for VLAN 20 for that layer 2 domain, but it doesn't have a layer 2 domain. I've done it the wrong way, but doesn't matter. A layer 2 domain for VLAN 30, then it doesn't really matter. Leaf 2 is not able to distinguish just based on the root target. This is for VLAN 10, this is VLAN 20, this is for VLAN 30, because again, this is at the control plane. So basically, it then imports everything, all those MAC address entries, even if VLAN 30 does not actually exist from a LAN perspective on Leaf 2. It will just import everything, because again, that root target is at the control plane, and we have on the left hand side imported and aligned 3 different MAC address tables, that's correct, and VLAN tables into a single MAC VRF with a single EVI1 and to a single VNI. So let's summarize this VLAN bundle service interface. So again, this is a many to one model. So this is where we were taking multiple or more layer 2 switching tables, and these were being aligned to a single MAC VRF. Now with that single MAC VRF, it would then have a single EVPN virtual instance and also a single VNI. So quite literally many to one. However, the downsides was that the MAC addresses have to be unique, and also that receiving device, Leaf 2 in this case, would import absolutely everything. And this comes back to that glorious root target. The root target being identified at the control plane, this actually identified the tenant rather than the end destination, end VLAN itself. However, what the root target also allows is to identify that MAC VRF on the receiving device, because it would be set to a particular value, and it would be the same from the export to the import in terms of the value. If Leaf 2 was set to have the same import in terms of the root target as Leaf 1 had for the export on the root target, it would import all of those MAC addresses, but it just generally knows from the value that's in this root target that is going to this MAC VRF. And we also talked about the VLAN. Now VLAN was advertised in the data plane, but it was not advertised in the control planes or CP. It wasn't advertised in the control plane because it doesn't really serve a function. At the control plane, we have a root target. The root target will identify a single, many to one MAC VRF. And so when Leaf 1 sent those update messages on the control plane to Leaf 2 over here, it would be able to identify just by using the root target, well, what MAC VRF are these actually destined to? However, we still need a way to identify, well, what is the end destination in terms of VLAN, i.e. 10, 20, or 30. And that is where the data plane came into it. And the data plane, in terms of identifying the destination MAC VRF, was identified by the VNI, which went from Leaf 1 over to Leaf 2, and the tag itself. So I don't actually think I gave a number, but let's say it was 5,000 in terms of the VNI tunnel, and the tag of 10, 20, or 30. Obviously, when that receiving device Leaf 2 received the tunneled packet and saw, you've got this tag 30, but I don't have tag 30 configured to me, it's just going to drop those packets because it doesn't have a local area network for them, but it still has to import all of those root updates, even if it doesn't have that VLAN configured to it, because this is the VLAN bundle service interface. And now we move on to the finale, the third type of this EVPN service bundle, and that is the VLAN aware bundle service interface. Honestly, who comes up with these names? They're just really long. Anyway, so like the VLAN bundle service interface, this is a many to one service interfaces. So we still have multiple or many layer 2 domains, layer 2 switching tables, layer 2 VLAN tables, same thing, and they are all being aligned and configured to one MAC VRF. The VLAN Aware Bundle service interface in that aspect is the same as the VLAN Bundle service interface, but obviously they are not the same thing. So let's just dive into that a little bit further. So if I just draw quickly layer 2 domain here for VLAN 10, I'm just going to draw a square around that. And we have another layer 2 domain for VLAN 20, and I'll draw another box around that. And of course, you know where I'm going, another layer 2 domain for VLAN 30. Now in the previous part, i.e. the VLAN bundle service interface, these were all aligned to a single MAC VRF, and we called that MAC VRF1. And in here you had your switching table, basically, where all those VLANs and those MAC addresses go into, and that MAC VRF was associated to a single, i.e. one EVPN virtual instance, and we called that EVPN1, and it had a unique virtual network identifier, and we called that 5000, etc. We've gone through this. How does this then compare to this VLAN Aware Bundle service interface? Because again, it's using this many-to-one concept. Well, as you can see here, we've still got our layer 2 domain for VLAN 10, we've still got our layer 2 domain for VLAN 20, and we've still got our layer 2 domain for VLAN 30. Now, of course, we are going to have a MAC VRF. So let's call this MAC VRF1. But within here, and I'm just going to draw it a little bit bigger, we are going to have a switching table. So I'm going to draw 3 switching tables. There you go, 3 switching tables, which does layer 2 domains directly map into. So VLAN 10 would go to this switching table inside that MAC VRF. Layer 2 domain VLAN 20 would go to this layer, this switching table in that MAC VRF, and layer 2 domain for VLAN 30 would go into this switching table, all within inside that same MAC VRF. So even though it is a many-to-one concept, you can see immediately by having these independent and individual switching tables inside the MAC VRF, we can then get away some of the problems when it comes to the VLAN bundle service interface. So no longer in the VLAN Aware bundle service interface do you need or require every MAC address to be unique. You don't need that in the VLAN Aware bundle service. Well, as far as I'm aware, you don't need to, because it makes sense, because each of these are going to a different switching table inside that MAC VRF, which is aligned to obviously an EVI, an EVPN virtual instance, and of course a virtual network identifier. EVI being at the control plane and VNI being at the data plane. However, when it comes to the VNI, we now have a separate and individual, a unique VNI for each one of these switching tables, which is aligned to each one of these layer 2 domains. So we might have this layer 2 domain for VLAN 10 going into this switching table inside the MAC VRF, and that's then aligned to VNI 5010. Likewise for VLAN 20, this layer 2 domain coming into this switching table in the MAC VRF, that might be aligned, configured to the VNI of 5020, and the same here for VLAN 30 through the MAC VRF going to VNI 5030. So immediately there you could see actually there are differences between the VLAN bundle service interface and the VLAN Aware service bundle service interface. The big keyword there, I think, is aware. With this service type, this EVPN service type, we are aware of these VLANs, these layer 2 domains, and as such they are getting their own separate, unique and independent switching tables, but all inside the same MAC VRF, and each one of them have their own independent virtual network identifiers. However, they all have the same Ethernet virtual instance, i.e. EVI1, I think we called it. So let's draw this out now. So we've got VLAN 10, VLAN 20 and VLAN 30. I'm not going to draw out the layer 2 domains, because at this point, if you're that far into this series, you know what a layer 2 domain is, and that VLAN obviously speaks for that layer 2 domain. And as we've just gone through, each one of these VLANs is aligned to an independent and unique switching table inside that MAC VRF. So I'm just going to do a switch in here. Appreciate my writing is very small, but VLAN 10 goes into this switching table inside the MAC VRF, VLAN 20 into this switching table inside the MAC VRF, and VLAN 30 into this switching table inside the MAC VRF. And as I also said, these then have a unique VNI. So that for this switching table here, which is aligned to VLAN 30, we said that had the VNI of 5030. And here, this is for VLAN 20, so we had that at a VNI 5020. And for that switch table there inside the MAC VRF, that had a VNI of 5010. And I've also said that these would all be within the same EVPN virtual instance, and we've called that 1 so far. So I'm going to do EVI 1 over on the left side and EVI 1 over on the right hand side. So let's say these VNIs, these tunnels here, they come in and they receive. So I'm just going to draw exactly the same but on the receive end. And so I've just finished drawing it out very quickly. So as you can see, the VNI 5010 goes up to this switching table inside the MAC VRF and out to MAC table 10, VLAN 10, the switcher table it goes. And it's the same for VLAN 20 and for the same for VLAN 30 on this leaf here. But as I said on the previous parts, leaf 2 here, this leaf over here, could have multiple EVIs. It could have EVI 2, EVI 3, EVI 4. So therefore, how does it know, and this is where I'm building on in terms of the advertisements, how does it know what actual EVI that these received packets and updates actually belong to? Just reading the VNI information here isn't enough. So let's build on that. So we've got EVPN, Ethernet Virtual Private Network, and we've got all those root type messages, the type 1, the type 2, the type 3, the type 4. I haven't gone into the type 5 yet, but this is obviously a control plane signaling protocol. And we have the VXLAN tunnels as well, which is a data plane tunneling technology. Now in the last part, when we were going through the VLAN bundle service interface, we said that the control plane EVPN, that no tag information was carried, and that actually the root target was defining the tenant itself, i.e. the tenant being leaf 2. Whereas at the data plane, the VXLAN VNI was identifying the end destination itself, being identified through the VNI and the tag. So how does that differ in this case? Well, in the VLAN aware, again, aware being the big word, at the control plane, we have that root target. And the root target is exactly the same as it has been in the previous videos. You've got an import and an export policy. They have to match. When you export a policy with a specific root target, if the receiving device doesn't have that same value configured on its import policy for that root target, it will just drop those packets. I.e., what's the root target? The target being the word. So we've got a root target within this VLAN aware bundle service, but we also, in this model, have then got that VLAN tag. Now, in the previous part, that VLAN bundle service interface didn't have that VLAN tag on the control plane, i.e. the control plane going from leaf 1 here on the left hand side over to leaf 2 on the right hand side. It didn't have it, but it is there in this model. So both the root target and the VLAN tag with the VLAN aware bundle service interface identifies to the receiving device what EVI, either EVI 1, EVI 2, EVI 3 or EVI 4 do these received update messages actually belong to. And for the data plane here, we have that unique virtual network identifier. It's unique because 5030 referred to VLAN 30, 5020 referred to VLAN 20, 5010 referred to VLAN 10. All those unique VLAN layer 2 switching domains on this side of the network. But here, when we talk about VXLAN, this VNI is identifying the MAC VRF of the receiving device. So it's almost flip side. It's almost vice versa, where the VLAN bundle service interface we had, and I'm going to draw this in red actually. So in the VLAN bundle service interface for the control plane, it was the root target only, which identified the receiving EVI, the Ethernet virtual instance, and because it was a many-to-one, of course, by function of that MAC VRF as well. And with the VLAN bundle service interface for the data plane, we had that virtual network identifier, but then we had the tag information as well, i.e. it was either tag 10, 20 or 30 if you recall. So now you can see, that's what I mean by its flip side, it's vice versa. With the VLAN aware bundled services, for EVPN at the control plane, we have the root target, but also now the VLAN tag is carried on the control plane in those root update messages, the type 2s, type 3s, type 4s, etc. But for the VXLAN data plane tunneling, it is the VNI, the virtual network identifier only, which identifies the receiving device's MAC VRF, because again, you will have EVI 1, 2, 3, 4, and as such you can have MAC VRF 1, 2, 3, 4, keeping it simple. And this is where, and I haven't covered it yet, and I'm not doing so on this video, but this is where the root type 5 comes into it. The root type 5 is pretty much using the VLAN aware bundle service interface, because we are aware of those VLANs. We are aware of how they're being mapped into an independent switching table inside that MAC VRF, and they have their own virtual network identifier, yes, within the data plane, but at the control plane, so I'm just going to do DP there for data plane, but at the control plane, so I'll do CP here, you have all those update messages, so in this case that would be the root type 5, which will be a later video, but within here you will have the VLAN tag and the root target as well. And all of that together makes this very, very powerful, because the root type 5 is basically advertising an IP prefix over a DCI, data center interconnection or interconnectivity, tongue twister there. But using this VLAN aware, we are making those different peering edge devices over that DCI aware of, okay, what VLANs am I receiving, what IP prefixes belong to that particular VLAN, and what MAC VRF does this actually belong to when I'm importing these update messages, and what EVI do they actually belong to as well. So that's why I wanted to cover this first. So there is a link here between the VLAN aware and the root type 5. So the root type 5, and I would say that this is absolutely a common deployment for that data center interconnectivity and maybe for that WAN, because we are bundling at the end of the day. We are bundling VLANs into a MAC VRF, but we're keeping awareness. We're keeping awareness in the aspect that every VLAN has its own switching table inside that MAC VRF. And then we're using those root type 5 messages to advertise that awareness over that DCI, over that WAN. And so there we go, everybody. That is the end of this video. That is the end of this part 7 in this EVPN-VXLAN series. We've gone through quite a lot of information. It's all been around the EVPN service models, which are the VLAN based, the VLAN bundle, and the VLAN aware bundle service interface. And that's why I highly recommended at the beginning you start off with, if you haven't seen them, parts 1, 2, 3, 4, 5, because they are covering the fundamentals and building up from there. It's a logical process. But as we've seen and gone through in this video, the VLAN based service interface is very much a one-to-one mapping, where you've got that specific layer 2 VLAN domain with all those MAC addresses, and that is mapped, aligned, configured to a specific MAC VRF switching table, and that in itself has its own EVI, EVPN virtual instance, and of course a virtual network identifier separating the control plane to the data plane there respectively. But then we saw actually when we went to the VLAN bundle and VLAN aware bundle service interfaces that they then moved to a many-to-one mapping, where we are taking multiple, several, or many, I like the link there, but we're taking many VLAN layer 2 domains, and we are mapping, aligning, configuring them into the same MAC VRF, but depending on that service interface, they may have one switching table, or they might have independent and individual switching tables inside the same MAC VRF. And that is really one of the differences between the VLAN bundle and the VLAN aware bundle service interface respectively. So there was a lot of information we went through there, and I'm trying to work on a cheat sheet, a comparison really to go through all of this information. But of course, there's quite a lot of information in terms of what does the root target identify, what does the data plane using the VNI identify, and is it based on this service interface, on that service interface. So it's quite hard to get a comparison actually. But nonetheless, I hope you found that informative. I hope you found that useful. If you like this content, if you like my channel, please give me a thumbs up. It's the best way to support my channel. Any questions or comments, please let me know down in the comments box. I'm loving hearing from you guys. Other than that, thanks for watching and goodbye.